Hello. Thanks very much for waking up this early in the morning, the morning after the big party. I know it's painful. I'll try not to scream or move too fast so that I don't give you, headaches or exacerbate your hangovers or mine. So the first thing I'd like to just mention briefly is that originally this session was going to be about developing a multiplayer game in Silverlight, and it was going to be based on a project that we're currently working on. Unfortunately, we submitted this talk about 4 months ago, and as anyone who's worked their way through the vendor program of a large company knows, things can get slowed down a lot. And so the project is not really far enough along that I feel comfortable talking about it. And so it's going to go from building a multiplayer game to building multiplayer games in Silverlight. And so originally I'd hoped to talk about a lot of technical specifics on a particular game. Instead, this is going to be a little bit more general, looking at sort of the market and what are the market opportunities in this space, digging into some of the technical skills that are required to build both casual games in general and also multiplayer games. Looking at the technology that's out there right now. So what are the major platforms? Looking at sort of in that context, what are the challenges that you're going to face? And if we have some time at the end, do a little bit of Q&A. Originally also Mike Downey, who's in the front row here, was going to join me on stage for some of it. But we came to the arrangement that I would take any glory and he would take any blame. So if you like the talk, that's all me. If it sucks, it's really Mike's fault, and I apologize for him. So let's take a look at the platform, what we have access to in Silverlight to kick things off. So Microsoft provides this kind of interesting platform where we can build games for all these different environments, right? We can build downloadable games for the PC. We can build web games using Silverlight. We can now build games for Windows Phone 7. And of course, we can build games for the Xbox. And these are, in terms of actual development, they're still slightly different platforms, right? We can work with XNA. We can work with the Silverlight stack. But you can definitely see a move to consolidate a lot of these things. And even today, it's not that difficult to move game logic and things like that across these different stacks and deploy it in multiple environments. We also have a lot of back-end tooling that we can use when we're building multiplayer games. Windows Server, obviously. Windows Azure, which particularly for multiplayer games is a pretty good technological solution because it means that you can deploy servers for a game, and that stack will ramp up as your players are added, right? You don't have to go out and buy new hardware, deploy new servers, worry about the interconnect between those servers. You can just deploy it all onto Azure and let the cloud worry about scaling and things like that, right? And then, of course, we have Xbox Live, which isn't presently available in Silverlight, but you can see it sort of moving between all of these different environments that we have access to. And so it makes sense, at least to me, that one day we'll probably see some hooks into Live through Silverlight. And Live provides us with a lot of capabilities around social networking from a gamer perspective. So setting up matches, doing notifications, tracking accomplishments, that type of thing. And so the ability to tie into that could be really interesting. Again, some of the tools that we're working with, Silverlight, XNA. You can actually utilize parts of XNA inside of Silverlight using something called Silver Sprite. So you can leverage parts of that. Some of the libraries that are available there, some of the physics, that type of thing. And of course, the tools that you're all familiar with, Visual Studio, Expression, .NET, etc. So why get into game development? What are the market opportunities? Well, we actually have a really interesting demographic when we look at casual games. Some of this actually surprised me. So unlike traditional gaming, the casual game market is dominated by women gamers. We're looking at like a 65 to 35% split. And this is actually really good to know because women control the pocketbook, right? They make more purchases than men do. And so if you can attract a female audience, there's a lot better chance that you can entice them with microtransactions and downloadable purchases and stuff like that. Unlike me, who has to go and ask my wife for permission to buy a new game, she'll just buy it. So it's actually a really great market to get into. It's also quite diverse in terms of who's playing these games and who's buying them. We have a pretty even split between the North American audience and the European audience, but we're seeing this huge surge in Asia. Already, the number of gamers in Asia, like the number of players of casual games in Asia, vastly exceeds North America and Europe, and this is growing a lot faster than these more traditional markets. I saw a number the other day that there were, in 2009, $7 billion in virtual goods purchased in Asia. So there's a lot of money going into this. If you look at the social game market, something like 70% of game plays right now in social gaming, which is mostly through Facebook, are occurring in Asia. So big market. Another thing that's kind of interesting about the demographics is that the age split is basically straight across the board. Unlike traditional gaming, which kind of hits like the youth market and young adult market, the casual game market is almost even, all the way from like children up to about the 65-year-old demographic. Past that, it drops off pretty significantly, but everyone is playing these games, so it's a huge market. This is where the market's going. You can see huge growth, right? This is generated from online games, so things like microtransactions, ad revenue, that type of thing. We're looking at 20% growth per year right now, and that growth rate is actually going up year to year, and it's continuing to grow even through the global recession. So, again, huge market. Downloadable casual games, so we have online casual games, destination games, things that people go to and play online, and then we have downloadable games, which often have a hook through an online game. Downloadable casual games, we're looking at, again, just tremendous growth, from $600 million in 2007 to $2.1 billion in 2008. And again, if we look at that technology stack that we have available to us through Microsoft, the leap from a Silverlight online game that you can use to like tease people in and get them interested in your game to a full desktop game, that transition is fairly simple, right? We can reuse a lot of those assets between the Silverlight deployment and the desktop deployment. A really important and emerging portion of the casual game market is social games. So these are games that are primarily played on Facebook. There is also a smaller secondary market in MySpace, but really Facebook is the big one. And really this is so new and so early that there really isn't a lot of numbers available for it. Social games have just really come into existence in the last couple of years, but seeing just like amazing growth. One of the examples that most people are familiar with, this is like the big poster boy for the space right now, is Farmville. Farmville is a Flash game deployed through Facebook, and they've had like amazing numbers. So it was developed in just 5 weeks. It got 1 million users in the first 4 days that it was deployed. It got 60 million users in the first 4 months that it was deployed. And it's up to over 82 million users in just 9 months. The company that builds Farmville, Zynga, they are estimated to be making about $200 million. They're a private company. They're pulling in an estimated $200 million a year through micropayments, ads, and offers that they basically ask people to like sign up for different offers online, and in exchange they get things. So micropayments is really the big thing here to pay attention to. People will pay like $5 to buy pumpkin seeds, so virtual pumpkin seeds. They'll shell over real money so that they can grow pumpkins online. If we could get this kind of passion behind growing real food, we'd all be fat and happy, right? So where's the money coming from in this space? We're seeing direct sales to the consumer, obviously selling downloadable games. One of the biggest areas from a developer perspective is selling or licensing a game to a distributor, so a game portal or publisher. You can do advertising. Obviously, a lot of games now are using in-game advertising, so they'll display advertising between levels, that types of thing. Premium subscription, so gaining access to better versions of the game in exchange for a monthly payment. I talked about microtransactions, which are probably the largest growing section. And of course, as developers, we shouldn't overlook the opportunity for indirect revenue from this space, right? My company, pretty much all of our revenue from gaming is indirect. So we build games for brands. We build tools that some companies use to build games, that type of thing. So one of the easiest ways to get into making money with games is indirect, but there's more money to be made. If I was a smarter business person, I'd figure out how to make residual soft games. So that's kind of the market. So let's talk a little bit more about like who builds these games and what you need to know to do it. Obviously, we have designers and developers involved. You can see that the US makes up maybe about a quarter or so of the market in terms of who's building these games. And we have a slightly higher developer to designer ratio. Obviously, these groups are working together. And I think that this ratio is actually changing more towards developers as games get larger and more complex, right? You still have roughly the same amount of designer work, but the developer portion is going up fairly significantly. At least that's kind of the sense I get, purely anecdotal. In terms of what types of companies are doing this, in the past, so even today, there's a lot of companies that are just, or a lot of people that are just building these games basically for fun, like a couple of developers that like games that, build these games in their spare time, and when they finish it, they license it out to a distributor or publisher, maybe make some money, maybe don't make any money. And this has made it kind of a challenging market to get into until recently, because a lot of the content is being built by people who really don't care about whether or not they make money off of it. There's obviously been a market for companies like my own that build these games as a service, right? They provide them to agencies and to brands and attach advertising to it and create an experience around some brand. Or they build it for a company that wants the game specifically to deploy. What we've been seeing in the last couple years is, maybe even the last 3 or 4 years, is the entry into this market by much larger companies. I mean, EA has a large dedicated casual gaming department now. We're seeing large dedicated companies like Zynga that are just building casual games and making a lot of money doing it. And so the budget for these games is starting to go up, and we're starting to see much more interesting things come out of the space. And there's a lot more opportunity to make money on this as a developer than there used to be. Again, you used to be competing against people who were going to do it for free, and it's hard to compete against that. I think this slide's in the wrong place, but I'll talk about it anyway. So I think probably the most interesting thing about Facebook, at least from my perspective, is that Facebook is going to be rolling out a new API around credits, which is going to make things like microtransactions way easier to do. It's going to make it so that players of casual or social games on Facebook can buy Facebook credits, and then they can apply it to the games that they want. So for a developer, you don't have to worry about all the transactions anymore. You just have to worry about enticing users to use their credits in your game. And that's going to make things way easier for you, and it's going to make the market really interesting. I think everything else I pretty much addressed already. So what do you need to know if you're going to enter this market as a developer? I think there's a lot to be gained from doing game development. I've worked on a lot of different types of development, everything from sort of interactive experiences and applications through games and installations and those types of things. And I think games are one of the best types of development to really learn a language. It also, if you like gaming, building games can be really fun too. I mean, part of building a good game is testing it a lot. But you do really need to have this sort of creative bent, and you have to be at least partially interested in the design side. I think, and again, I come from a background where the bulk of my work is application development, so I'm not just a game developer up on stage telling you, hey, game developers are awesome. I really think that game development and then multiplayer game development is like a superset of skills over regular application development. There's certain things that you don't need to be able to do quite as well as a game developer that you have to do as an application developer. But in general, you have to know pretty much everything you need for application development, and then a whole ton more. And then for multiplayer game development, there's another set of capabilities that you need to have. So let's take a look at that. So for game development, obviously the performance of a game is paramount, right? We need to wring as much out of it as we can to give people the best experience that we possibly can. We also, as much as possible, don't want to have their fans going crazy the whole time they're playing our game. So you need to get really good at optimization. And unlike application optimization, where we need to know a bit about everything, but a lot of it really focuses on code performance, in game development, we really need to be extremely holistic. So we need to know, how is our code going to perform? How is our graphics going to perform? Obviously, there's a really big focus on graphics performance. And we need to get a little bit more creative with our architecture and need to know a lot about algorithm optimization. So code optimization, digging deep. You want to know how your compiler works as much as possible. You need to know the limitations of your runtime, what's going to get JITted, what isn't, what's managed code, what isn't, knowing how the timing model works, and knowing when your GC is going to kick in and when it's going to run, when it's going to slow things down, and trying to work around those things. Silverlight right now doesn't have a dedicated profiling tool in Visual Studio. My understanding is that's coming in 10. But we do have tools like Xperf, Silverlight Spy, and Ecotech Profiler. I took a look at all of these. It looks like Ecotech is probably the best tool available right now. You can do snapshots, find out what methods are running, what's taking up the largest portion of your CPU. And it seems like a really good tool, so I'd recommend checking that out. Silverlight Spy doesn't give you quite as much information. It's going to tell you more instantaneous information. So how much of the CPU are you using right now? How much memory are you using? Those types of things. We also have to know a lot about graphics optimization. So we can't just worry about code. So for example, what is the impact of vector graphics versus bitmap graphics versus cached vector graphics? When does GPU acceleration kick in? So we've been doing some testing, and at this point, you really can't trust what you read in the documentation. We've had a lot of issues where vector caching isn't giving us the results that we'd expect, that the caching is just not working in certain instances. There are some known issues around GPU acceleration where it doesn't work in certain instances. So understanding all of those issues and accounting for them is really important. I personally haven't found any really good tools for this. There's a property that you can set that will allow you to see when vector caching is working or not, which is helpful. But there's not really a lot that lets you benchmark graphics performance right now. So I've found that we're doing a lot of just sort of running code, watching the frame rate, seeing what we get out of it. It's not very precise, it's not very scientific, but at the moment it seems to be the best that we can do. If anyone knows of a better solution, I'm very interested in it. So as developers, obviously we need to know a lot about architecture. And in application development, we're really worried about maintainability. We're really worried about abstraction. We're rolling in lots of different patterns to make our code easy to work with. When we start getting into gaming, though, because we have such a high focus on performance, you need to get a little bit creative sometimes. You need to sort of bend the rules that you're used to, and you'll find yourself using a little bit higher coupling than you might otherwise, right? You need to take advantage of really fast method calls, and you'll make compromises. Inlining functions that you might not otherwise inline, that type of thing, in order to get the best performance you possibly can. I'm not saying throw away architecture. I'm not saying write sloppy code. But you might find that when you get to the optimization stage, you're making more compromises than you would in an application. Just because rather than in an application where you run really CPU-intensive code sort of on demand, a user clicks a button, you run some intensive code, you spit out a result. When you're writing a game, that code might be running the entire time the game is open. And so we really need to get the best possible performance we can. Algorithms. So a lot of game development is about finding the right algorithms. A lot of the common tasks, things like pathfinding, we have tons of options in pathfinding. There's algorithms like A*. A* gives you perfect pathfinding results, right? It'll always give you the best path, and it has a lot of great options around, weighting areas of the map and things like that. But it also grows in an exponential fashion. It's very expensive to run on large maps, and it doesn't give particularly good results if it doesn't find a match. You can kind of weight things and try and get a decent result, but it's not really designed for that. We also have options like edge tracing and move towards, which are much cheaper algorithms, but don't give as good results. So you spend a lot of time sort of deciding which is the best algorithm for your specific need. You'll get into spatial division, working with octrees and things like that, although octrees are more 3D. Data manipulation, you're going to work with large sets of constantly evolving data, and things like physics simulation. And so you really need to be able to not just use algorithms, but you need to be able to evaluate them. You need to figure out whether or not they work best in your specific scenario, and often you need to be able to adapt them yourself. So, for example, years ago, I combined edge tracing with move towards to get this sort of custom algorithm that I wrote that was really good for simple casual games, but doesn't make any sense at all in sort of larger games with better processing. This was back in Flash Player 6 or something, so CPU was really, really limited. So I had to build this custom algorithm to get the results that I wanted. You're going to have to know some math. So obviously, basic math, you need to be able to work with multiplication, division, addition, subtraction, modulus, these types of common things. You need to be really comfortable interchanging those things and knowing how to combine them to get the results that you want to get. Spatial math, so how do we move things around? How do we calculate how far they are from each other? Bitwise operations, this is largely from an optimization perspective because bitwise operations allow us to do some types of calculations much, much faster than using standard math. And you're going to need to know at least some basic trigonometry, because you're going to have to be able to make things turn to point a particular location, or those types of things. More advanced trig. I would say, calculus definitely pays off, but at least in my experience, it's been more an understanding of how calculus works. I can't think of any occasion that I've actually started doing real calculus, but the concepts behind solving problems is really helpful. And of course, understanding basic physics so that you can sort of emulate those in your games. Even if you have a library to rely on, sort of having a general sense of physical sciences and physics can let you judge whether or not things are looking realistic and whether you're getting the right results. This is all kind of 2D stuff. Moving into 3D, the math gets really complicated. Luckily, there's libraries to help out. In Silverlight, we're not too worried about this space yet, but it gets interesting, like quaternions, which still give me horrible, horrible headaches. I think as a developer, you can build applications without loving applications, without loving the application, the type of application you're building, right? You can build giant enterprise applications without being excited about giant enterprise applications. But I don't think that's true with game development. I think to be able to build games, you need to at least like games, if not love them. The experience of the game is so tightly tied to the development that there's just no way to build a great game without being able to play it yourself and enjoy it and know and have played other games like it and be able to bring those experiences into your game and make it phenomenal. I just can't imagine building games without actively being a gamer. So again, as a application developer, you might be able to get away with sort of basic knowledge of graphics integration and sound integration, right? You can take a skin from a designer, integrate it into your application, and not really need to know too much about the tools or how it's all going to work. As a game developer, I think it's fairly essential that you're really familiar with this process, both bringing stuff into Blend, spitting it out into your game, but also having some familiarity with the actual tool. So being able to go back into Illustrator, tweak some graphics, bring it back in, because there's a lot of iteration in game development. You're going to get some assets, and you're going to realize they're just not quite what you need, or you need them broken apart in a slightly different way. And while you don't need to be able to go in and design this stuff yourself, it's going to really speed up your workflow if you can go back and make these changes really quickly in Illustrator or Photoshop and bring them back into Blend, right? As opposed to having to go back to the designer and say, hey, I need this 2-minute task done, wait around for them, get it back, and pull it back in. So I think this is important. Most game UI is not managed UI. We're not using a managed layout. Whereas most applications, we're going to use layout tools, right? So to build good games, you need to be really comfortable with moving stuff around on screen yourself, with managing the layout of things. So working directly with their top left properties and moving them around on a canvas. We typically use a canvas as opposed to a grid because it's completely unmanaged. Working with the origin point, working with transform groups, that type of thing is really important in game development because you're going to be managing the position of everything on screen. It's also really important that you have a great understanding of how interactions work, because it's not just going to be typing text into a text box generally. You're going to have to know how to capture keyboard input regardless of where it's happening. You're going to have to track whether or not a key is still down. You're going to have to deal with key repeats. I've seen many games by inexperienced developers where they don't deal with the key repeat. And so they have something that happens every time the key repeats. And then depending on the computer that you're on and what the key repeat rate is set to, you get completely different gameplay experiences, right? So you can use something like the key handler class, which lets you track whether or not a key is still down. So you can operate on a tick and say, if the key is still down, then do this, as opposed to doing something when the key is pressed. And you want to get really familiar with like dealing with mouse interaction in an aggregate environment. So if a user clicks your tank, just determining where they clicked on that tank, you might want to handle it with a listener on the tank itself. You might want to handle it with a listener on a parent, right, and on an enclosing canvas or something like that, so that you can get these kind of more aggregate responses to things. And you'll find that you're doing a lot of like click and drag and that type of thing that is maybe a little bit more complicated than what you'd normally deal with applications. Spiking is something that has been a huge part of the work that I've always done. Spiking is basically just the process of creating these really tiny experiments to test out things that are going to go into a larger application. So you might test out a specific interaction, or you might test out an algorithm, or you might test out just a socket connection and to get your messaging working before you start to roll that code back into your larger project. And this is really important because games are like these very, very integrated, complex webs of communication, and it can be very difficult to debug parts of that game once they're plugged into the main game code. And so building out some of these things as separate elements allows you to test them separately before you throw it in. And so if you know that it's working before you stick it into your game, and you stick it into your game and it stops working, then you know obviously that something is wrong with the interaction between that element and your main game, as opposed to it being wrong with the class itself. I've found, so most of the work that I've done has been in Flash, and Flash is like a great tool for spiking. It's like a zero commitment tool where you can like create a new file, write some code, test it, and not even save the file. Silverlight is a little bit more difficult, but we've been working on some sort of approaches to make this easier. We found sort of two ways of doing this. One is, and this is the one that I think we've kind of tended towards, create a solution that's for your spikes, create a new web project inside of that solution, set the start action for that web project to the current page, and then each new spike that you do can be a new project, and you can point it off to a shared class library. And what this does is when you actually compile this, it's going to launch the directory that all your spikes live in. And so you're just going to get a directory listing in IE, and that lets you just click on the spike that you're currently working on. So it gives you a fairly decent workflow for creating really fast tests and saving the results. The other approach that we've been playing around with, but hasn't been quite as popular in the office, is to build a single project for all of the spikes. Each new spike is its own user control. And then we either, in the code itself, swap the root visual, or so we'll like go in and type in the name of the class that we want to test and run it, or the name of the user control that we want to test and run it, or we'll put in a little drop down and we'll swap in the test that we want to use as a child of the root visual. And we've also written a little harness that uses isolated storage to remember what the last test we ran was, so we can just rerun the whole project and it'll bring up the same test over and over again until we select a different test from that list. So spikes tend to be very short-lived. So solution like the first approach I showed you tends to work because you're not usually switching between your spikes a lot. It's usually create a new spike, work on it until it's working or it's proven what you're trying to do, and then pull that code out, bring it back into production, and work from there. So this approach has the potential disadvantage that there is other things around that could affect. I mean, there's not a lot of other code running in the application, but there are other things that could potentially affect your spike, right? It's not a pure spike. Obviously, games are all about moving stuff around on screen. So you need to know how to do programmatic or procedural motion. You can't just rely on storyboards to do everything that you want. I know chatting with some of the Silverlight engineers, they're always like, why do you want to do all of this in code instead of using storyboards? And I mean, in games, you really need to control how everything is moving. You need, because everything changes every frame, or every tick. So you can't rely on a storyboard and be constantly changing its values, right? It's just not a very efficient way of dealing with things. So you need to learn how to do programmatic eases. You need to learn things like acceleratory motion, which is basically where we accelerate towards an object and then slow down as we approach it, or towards a target and then slow down as we approach it. Need to be familiar with working both with Cartesian motion, so just changing x and y by constant amounts, or working with a vector, right? Working with angular motion, where you can set an angle, a speed, and calculate the x and y components every frame, every tick. So this is really important. And there's a lot of, again, most of my work has been in Flash, and I would really encourage Silverlight developers to leverage the Flash community to learn a lot of this stuff. There's tons of code out there in the Flash world. I mean, the Flash community has been through all of this stuff, and ActionScript 3 isn't that different from C#. It's actually really easy to take some of the information that's out there and apply it directly into Silverlight. Most games, not all, but most games require some form of collision detection, right? We need to know when two things run into each other. We have a lot of options for this. We can work with the rectangular bounds of things, and we can use methods on the rectangle to find intersection with a point or intersection with another rectangle. We can do point-to-shape collision detection using visual tree helper.find elements in host coordinates. So this will actually take the real shape of an object on the screen, and you can compare a point to that, and it'll tell you whether or not it's collided with that. You can do that by just setting the host, the host that you want to compare to the element that you're trying to figure out whether or not it hit. So if you have like a spaceship running around on screen, you can say, find elements in host coordinates on this spaceship, and it'll return you a list of anything that was under that point, but only within that host. And so if it returns anything, then you know that that point is colliding with the shape on screen. You can do mathematical collision detection, so things like circular collision, really easy. And it's actually possible to do shape-to-shape collision detection. I've seen one implementation of this which wasn't really fast. By writing a custom shader, we can actually take the shapes of two things that are on screen. We can find, using just rectangle math, the intersection between those shapes, and then we can draw them on top of each other in a writable bitmap and figure out whether or not the resultant pixels are from both of them overlapping. And if they are, then we know that the shapes collided. So it's actually possible to do shape-to-shape collision detection, even though it's not really supported directly in the Silverlight API. So that's kind of some of the things that you need to know for game development. Multiplayer game development adds yet another layer on top of this. We have sort of two core models when we're doing multiplayer game development. We have the server as the host or the client as the host. So server is the host. This is just all referring to where the game state and significant logic resides. So we're not worried about where the UI logic resides. That's always going to sit on the client. But things like determining when something dies or when something gets built is significant logic, right? It has a major effect on the gameplay. We need to decide whether that's going to be decided by a server or whether or not the clients are responsible for that type of thing. If it's on the server, it's obviously a lot easier to prevent cheating, right? Because your game logic is running, and basically your clients are just acting as thin clients, or just visualizing whatever the server tells them to visualize. When a client is managing this stuff, then obviously we're really open to someone modifying the client or doing packet sniffing or those types of things, which is much more prone to like cheating and hacking and that type of thing. We have a few different game types that you'll see. We have turn-based asynchronous or sort of the standard social model. And I'm talking more about like sort of chat social, things like Club Penguin, if you've ever seen that application. Or even Second Life is kind of an example of this. These are games where we're not too worried about the intersection between characters, between players, right? So either players are playing at different times. So in a turn-based asynchronous game, we have one player play, they finish, notification goes out to the second player, they come in, they do their turn. And so it's a multiplayer game, but there's never multiple players playing at the same time. We also have these like social games, things like, again, Second Life, Club Penguin, where there's a lot of players playing, but their interactions don't matter, right? Like you have a bunch of people walking around and chatting to each other, but the timing doesn't matter, right? As long as their chats show up within some reasonable amount of time, their little chat bubbles show up within some reasonable amount of time, they don't have any real critical interactions between each other. And so these are a lot more straightforward to write than network games, that multiplayer games where there's really critical interactions. Generally, these types of games, we can get away, with these social games when we want to go to something like a socket, but generally we can get away with a sort of more traditional networking approach. So the user does something, we send that to the server, we get a response. We can just go through HTTP. Pretty straightforward. You can use WCF or whatever for this. With turn-based asynchronous, we're going to require a separate messaging system. So in a social game, we might just take advantage of Facebook's messaging. If we're not using Facebook, we might have to have an email server or something like that so that we can ping the next user to come in and play the game. Because in turn-based asynchronous, there are gaps between when the players are playing, everything has to live on the server, right? The state has to be maintained by the server so that it lives between different sessions. Another option we have is turn-based synchronous. So you can imagine this as like a chess game where we're both sitting, we're both sitting at separate computers, but we're both playing at the same time. So I take my turn, you take your turn. I take my turn, you take your turn. And this is, again, reasonably simple to deal with because we don't really have collisions. We don't have to worry about the two players making decisions that are going to cause a conflict. And we also don't have any real dependency on latency. If it takes a second for the command that's issued when I move a piece to go through the network and get to the other player, it's not really going to affect what's going on because they're not playing at that moment. And so we can still use things like HTTP requests. We can even go so far as to do polling, so just requesting every 10 seconds or so, has the other player made their turn? Have they finished? And depending on whether or not you're too worried about cheating, we can have the state live anywhere, really, right? The clients can remember the state because this game only lasts a single session. Where things get really interesting and really complicated is when we get into real-time games. So this is where all the players are playing at the same time. Their interactions are potentially conflicting, right? So we have this big dependency on latency. Let me show you just a very simple example of latency. I'm going to launch. So this is just a very simple little sample that we built. So this sample is actually creating a socket connection out to an external socket server. That server is running a server called Union, which is a multiplayer, multi-user server normally used for Flash. It actually supports a bunch of different environments. It's actually really easy to write a layer to support Union. And basically all it does is if I send a message to it, it broadcasts that message out to anyone else who's subscribed to the same room. And so both of these clients are subscribed to the same room. And again, this message is going, I think, to our office in Edmonton, and then it's coming back. So I can click, and you can see that we have a little bit of latency here. I have a really good connection, but you can see that there's that little bit of a delay between when I tell it to go somewhere and when the other one starts moving, right? And this is really where all the complications in building multiplayer games come in, because we need to deal with that time lapse. Because if, for example, I tell my guy to shoot and the guy on the other end of the wire tells his guy to shoot at the same time, and so both the guys shoot, my client might think that I shot first. You know, did Guido shoot first or did Han shoot first? I don't, you know, it all gets confusing, right? Especially when you involve George Lucas. Yes, the one Star Wars guy that laughs at the joke. So it didn't help that I got the name wrong, but so we need to try and deal with this this latency, and so when we're dealing with real-time messaging, we can't just send updates. We need to send a bunch of different types of a bunch of different types of messages. We need to send every interaction, every significant interaction that the user has in the client. So if I order a unit to go somewhere, obviously that interaction needs to be sent to the other client so that they can also move that unit around. I need to get significant game events, right? So someone has to be in charge of whether or not something gets blown up. I can't have every client deciding which units get blown up, because they might make different decisions based on that latency, right? And so one client or the server has to decide, has to own the game logic and has to own the state. And so whoever owns that state has to send out these small game events to say, this unit got blown up, this unit lost this much health. And so as part of your game development process, you have to decide what is a significant game event. What do you need to use that pipe for, right? Because we want to send as little data as we can so that it travels as quickly as possible. And then every once in a while, we also need to send a state update, right? We need to be able to say, this is what the game looks like right now, so that all the clients can synchronize to that, right? So that we don't get these ongoing minor differences that build up and give us a huge difference in the game state between clients. And this can either be partial state information or full state information. So you're basically going to be pinging back and forth these interactions that are whatever the users are doing, right, so that everyone can update. When significant things happen, you're going to send little messages to say something significant has happened, act on it right now. And then less frequently, although frequently enough that we don't wind up with a huge delta, so maybe every second or every couple of seconds, we're going to send a state update. And we're going to say, this is exactly what the game looks like, you know, rebuild to look like this. And you're going to have to deal with things like interpolation, so that if you're slightly different on your, like if client A is slightly different than what the super client or the host says the state should be, we don't want to have everything suddenly jump around on screen. We need to interpolate between where we are, where we're trying to go, and where the state says we should be, right? So that we have this kind of smooth motion back into the correct data. So I talked about latency. There's some different strategies for how we deal with this. We're probably seeing about 50 milliseconds on that demo I showed you. But I mean, you should expect it. I mean, it'll actually get higher than 300 milliseconds, but I would say that the normal range is going to be about 60 to 300 milliseconds. And unlike large-scale games where a lot of this is going to be client-to-client, all of our communication right now is going to be client-server-client, right? So we have double the latency. And it means that in a case like what I was showing you, where I have two browser windows running side by side or two computers running side by side, it's still going to go all the way out onto the network and all the way back. So from an infrastructure standpoint, faster, servers with faster connections, servers that are closer to the gameplay areas. So a lot of sites, a lot of multiplayer games will have European servers, North American servers, and Asian servers. This will reduce the latency to the server. If we have our game logic on the server, it means that the server can broadcast game logic instead of a super client having to send it to a server and then have it broadcast. So we have half the latency for significant game events and state updates. It also means that because we're having the number of connections, like the number of hops, our latency becomes more predictable because we don't have to worry about the communication variations in the communication in the latency between this client and the server, and then this server and this client, right? Which makes it harder to predict what our overall latency is going to be. We can also do things like calculate roughly what our latency is, and we can do things like if the user clicks on something and tells it to move, and I know I have about 200 milliseconds latency out to the other clients, then I can delay that interaction for 200 milliseconds before I start it. And what that means is that the other clients are going to get that message and start that movement at roughly the same time that I start mine, right? So we can fake the latency on our end to account for the latency that's going to happen on the other clients. Another thing is just game design. If you have like a numeric health readout, and then it's very easy to tell that there's a discrepancy between what you're seeing and what your friend beside you is seeing. It's very easy to tell that your guy suddenly exploded when he had 15% health, whereas if you just have visual health, your guy kind of gets beaten up and then he dies, then there's a lot of fuzziness there. And so users are a lot more likely to say, oh, he was getting beaten up and he died. That's fine. I expected that. Than if you say, this is the exact percentage of health that your guy has, and then all of a sudden you get a significant game event that says, that guy's actually dead, you've got it all wrong, right? So a lot of it comes down to game design. You will be, maybe you won't, but I was amazed by the amount of work people will put into hacking these games. They will sniff your packets. They will. One game company that I talked to that built a fairly popular multiplayer game online said that they've gotten to the point where they use the cheaters' documentation for their API, like their server API, instead of their own, because the cheaters have done a way better job of documenting it than they ever did. So they actually, when they're writing their stuff, they actually go out and they find these hacking websites and they look up the documentation on them. So you'll see packet sniffing, packet injection, right? They'll insert a packet that says, actually, I have 50,000 gold, and you need to deal with that type of thing. They'll also, Silverlight, the ZAP files, don't have any protection. When we're dealing with a client, we have to assume that anyway. We always have to assume there's no protection. But you will see people decompile your game, rewrite large parts of it, recompile it, play it with that recompiled ZAP, distribute it to other people, and you'll get a community of people hacking your client to give them advantages in your game, right? If your game is not built well enough to minimize cheating, it'll just send stupid things like they might put in a kill all button. Boom, nuke, everyone else dies, right? Or they might be more subtle. They might stick within the rules of your game and add bots, so things that'll help control the game for them and give them an edge in gameplay. You can't completely stop this. There's just no way of doing it. But you can minimize it by having more of your logic running on the server. Obviously, if game logic's happening there and the definitive state lives on the server, that's a lot harder for anyone to touch. And it means that you can check the information coming in from the clients for certain patterns and try and determine whether or not they're cheating. This can be expensive, though, right? It increases the load on the server. If you have a really popular game with thousands or millions of users, then running all the game logic, things like pathfinding, that type of thing, on the game server is probably not realistic. So what you can do instead is you can do random checks. You can have some of the logic live on the server. You can have it, run some of the same code and just validate things occasionally. So it basically says, oh, you sent me this. I have a little bit of extra time right now. I'm going to check that game logic, and if it's not, if I think it's wrong, then I'm going to flag you. And so you can also do, if it's client to client, you can do what I call honesty heuristics, which is basically if you have a super client that controls the game state, all your other clients still have to have the full game state. So they have a pretty good idea of what should be happening. And they're running the same logic so that they can display the game to you. So when they get a new game state or they get a significant game event, they can compare that to what they think should be happening. And then they can assign a rating to any discrepancies. So if it's just a difference of a few pixels, you might get like a 0.1 rating onto your honesty value. And if it's someone got killed that had full health, you might get like a 10 on your honesty value, right? So you're getting penalized for discrepancies. And every update, we reduce that value before we check it, and then we bump up the value based on discrepancies. And if we go over a certain threshold, then we basically say, you're a cheat, terminate the game, send off something to the admin to say, hey, this guy is probably cheating. Right? So we can do some things in client-client games that will help reduce the occurrence of cheating. But then it really comes down to these guys are going to decompile your game. They're going to find out where that threshold is, and they're going to build cheating systems that just barely stay under that threshold. Right? So also constant sort of adaptive development can help with this, where you're kind of changing changing how you do these honesty checks so that old hacked clients get flagged as cheats until they have the time to build the next version of the cheat. Of course, obfuscation can help quite a bit. It makes it harder to get into your code and find out what's happening, but it's not going to stop people. So just a quick look at the technology that's being used for games right now. These are the 3 core technologies that are being used. Java, I was actually surprised how much Java is still being used. I can't remember the last time I played a Java game, but a lot of the traditional portals still have a lot of Java games on them. Flash is the market leader right now. And of course, now Silverlight is sort of the new kid on the block. Java is losing a lot of market share. I think these are the main reasons for it. The tooling just isn't very good for building games. Not too bad for building applications, but really not targeted towards animation and interactivity. It's harder to get into, both for users. We're looking at a larger plugin size. There's a lot more fragmentation. And longer startup times, bigger game files, those types of things. So I think that's kind of why Java's going down. Flash has been gaining a lot of ground. This is obviously due to ubiquity. It's very easy for developers to get into. It means that people can get in and just start playing and building games casually, and then when they get better, actually start producing real work. It has pretty good code performance, reasonable graphics performance. I think the community is a huge part of this. Again, as a Silverlight developer, I would heavily leverage, if you're interested in getting into game development, I would heavily leverage the Flash community. And then I would really encourage you to share the things that you learn as a game developer, because this is one of the big strengths in the Flash world, is that the community has a lot of open source stuff. There's a lot of knowledge transfer. There's a lot of passion there. And I'd love to see the same thing for Silverlight. Silverlight's big strengths: great development environment, great tools for debugging. It's awesome that you can write C# everywhere you go, right? You can write C# on the server. You can write it for the client. There are some really good game libraries out there, although they don't tend to be Silverlight specific. but you can leverage a lot of that stuff into your Silverlight code, a lot of commercial components. And you can use some of the stuff out of XNA, as I mentioned before, using Silversprite. So you can take advantage of some of the physics libraries, that type of thing that exist in XNA in your Silverlight projects. Great performance. Code execution is phenomenal. Multi-threading means that we can pass off things like pathfinding and that type of stuff and AI onto a separate thread and have that run on a different core while our main game is executing. Some GPU support. Graphics performance really isn't quite on par with code execution yet, but it's still pretty good. We talked about this. Just the ability to move games between different environments is huge. The out-of-browser experience, I think, is actually phenomenal in Silverlight for games. Just that ability for a user to take a game, their favorite game, on the road without any real commitment is awesome. And that, wow, I think I'm 3 seconds left. And that wraps up. I'm happy to talk to anyone about anything, really. On Twitter, I'm gskinner, and this is my blog, gskinner.com/blog. Over the next couple months, we'll be working away on this game that we've started, and I'll be blogging, some of the code that we come up with, some of the things that we find, and just sort of about the general experience of it. So feel free to keep an eye on that. Thank you very much.